Jennifer here with NatureSolve, and we are back with our Utah Lake Jordan Canal water tests. So the last test we did, we have on this side an untreated sample that I've just stirred up, and we have our treated sample over here that I've stirred up as well. We're going to do one set of tests on the pH and the strip tests, and then after that we are going to let the sediment settle and test again. I did have the materials overnight stirred up quite a few times. Let's let this, there we go, get to where it's headed. And to prevent cross-contamination, I'm gonna go ahead and treat the test the untreated sample first. Yesterday we had about an 8.3 to an 8.37 across the untreated baseline. Now we have obviously moved the water out of its native waterways. We've kept it stirred up. The temperature in here and the humidity is a little bit different, so we do expect some parameters of the water to change. I'm getting an 8.1 to an 8.12. And that's where it's bouncing from. So let's do an 8.11, just for good measure. 8.1112, yep. Okay, we'll go right in the middle, 8.11. And now for our treated sample. We are at 7.38 to a 7.4. So we are going to put a 7. Let's see. 7. Let's do a 7.39 right in the middle there too. And we are at, let's see, time. All right, we are at 26 hours and a few minutes past when we first did our treatment and testing. I did take pH a couple hours ago as well, and there is a slight fluctuation there. They both have come down just a little bit more. I did go on a quest to get new test strips. They didn't have any nearby, so we will be getting some new ones of those shipped in. These are still going to give me an idea of the direction of things, but always verify in the lab and always use the best, newest equipment and test products as possible. This says it's about a 7.5 alkalinity. It's 120. Flick-free chlorine is 0. The total chlorine, the nitrates and the nitrites are still really off the charts high. Mercury is at a 0. I just don't really trust those extreme of colors, but I will verify against our lab tests as well. Lead's at a 20, iron's at a 0. Those are right in alignment with our tests from yesterday. Copper is between a 0 and a 1, we'll say 0.5. Fluoride 50, bromine 0, chromium 0. And hardness 250, carbonate root and cyanuric acid both at 0. So hardness 250, and then we got 2 zeros down there at the bottom. So won't expect anything too different there, and we really didn't, other than the change of pH from the 8.3 yesterday to an 8.15 earlier, a couple hours ago, to an 8.11 now in our untreated sample. And you can already see that sediment building up. We'll get a closer look at it later when this water has become much more clean. You do see a lot more sediment in the bottom of the treated sample. And the reason for that is because our microbiology is going to go to work and start to free up some of the materials that are locked into the water column and turn them into that fine sediment that you see on the ground. It's almost like a powder. And that is where you're gonna see a TDS spike, for example. If you're doing tests with our product, you're gonna see that total dissolved solid level jump initially, and then it's going to continue to come down and stabilize once the microbiology does its complete job. The tint in the water is from our molasses base, which for specific uses can be adjusted. We can change that up, but especially in really harsh climates, our microbiology likes it. If you give them a food source, why they get accustomed to where they're going. And so whether they're in the water or in the soil, microbiology, bacteria and fungi like to have a food source, why they adjust, and they can hypercolonize. Okay, let's take a look here. pH level about a 7.2 on these strips. The alkalinity is somewhere between the 80 and 120. Chlorine is 0. Total chlorine, nitrates and nitrites, whoop, still really high. So we'll verify that. Mercury is at a 0. Let's see, lead. Is a 20. Iron is a 0. Copper is a 0. Fluoride put that between the 25 and 50. Kind of a little off on color, somewhere in between those two. Bromine 0, chromium 0, hardness 125. And then we're not going to have any carbonate root or Cyanuric acid. We didn't have them just to start with at all, but just to verify. So there's our test strips between the treated and untreated water. This one is the treated, and this one's the untreated waters. So I'll keep these test strips. They become irrelevant fairly quickly. That water feeds off, but you can definitely see some differences in the shading as you go through testing. So that top one, let's see, that second one, the alkalinity, massive difference in those ones. So what does that look like? 80 to 120 compared to 120. Pretty big difference on the color scale, but once you compare it on the test strips, we're coming down with the treated sample. So I'm gonna go ahead and let these settle. We did test the pH. We've done the test strips. I'm going to see if my dissolved oxygen meter will work. Been having a little bit of a tough time with this guy. Okay, milligrams per liter. Let's see what we got. You want to put them in and give it a swirl. It's picking up all that light sediment at the bottom, turning it into a little mini hurricane. It is settling in at a 10.6. In our untreated, and in our treated sample, give it a swirl. Hmm, 3.2. Yeah, still not sure that I'm believing this thing. So I'm gonna go ahead and recalibrate there. Because I can't dip back into the untreated water now, I'm gonna need to clean off the test unit, but even after calibration, I'm not sure I trust this one. So we'll check back in on that later. Jennifer again with NaturSolve. We'll be back to test here in a little while once this water settles out.